We can use other shapes other than rectangles to calculate area. One of these shapes that we can use is a trapezoid. So to use a trapezoid, we just need to make sure we know the trapezoidal area formula, and it's y1 plus y2 over 2 times the width, or delta x. So we have yn plus 1, so the heights of the two successive terms. We take the average height, so we divide that by 2, and then multiply it by the interval width, and that will give us the area of that trapezoid. Example 1. Use the table of values and calculate the area using trapezoid. So we should just sketch out this area, or the points here. So the f of x, we have 0, 2, 2 and 4, so maybe a point around here. 3 and 10, maybe somewhere up here. 4 and 6, so maybe somewhere around here. 6 and 2, and 10 and 14, so way up here. Okay, so it's important to note that the interval widths are not necessarily going to be a consistent width. So in this case here, we're kind of going up like this, up again, we're going down, down, and then all the way back up to here. And underneath these curves, underneath these points, we can draw in trapezoids. So we just want to calculate the areas of each of these trapezoids. So the area, this first area, we're going to take the first two heights. So we're going to say that the area is equal to the first two heights, 2 plus 4, divided by 2. And then we're going to multiply it by the interval width. So the width between 0 and 2 is going to have an interval width of 2, plus the next two heights, so it's going to be 10 plus 4 divided by 2, and that next interval is going to have an interval width of 1, plus, okay, so that would be this one here. The next one here, we're going to have the heights 6 plus 10 divided by 2. So the interval width in that case again becomes an interval width of 1. And I'm just going to have to go to another line here. So plus the next one here, the interval is, or the heights are going to be 2 and 6. So 2 plus 6 over 2. And again, that interval width between here and here is going to be 2. And then the last area, this area represented in here, the heights are going to be 14 and 2, so 14 plus 2 divided by 2, and then this interval has a width of 4. Okay, from 6 to 10 has an interval width of 4. So these individual areas look like this. This individual area looks like it's 6, 7, looks like this one is 8. The next one is going to also, looks like it's also going to be 8, and 16 divided by 2 is 8 times 4. This one has an area of 32. So the area, just do some colors so we can see it a little bit better. So the area that we're going to calculate is going to be 6 plus 7 plus 8 plus 8 plus 32, and we end up with an area of 61 units squared. In the next part, it says, if f of x represents the velocity of a person moving, estimate the distance traveled. So first of all, this function is velocity. So we're just going to maybe replace that with a v of t. Okay, so we'll measure that. Let's just say that's in meters per second. And we want to calculate the distance traveled. So again, the distance is the absolute value of displacement. So we're not, although in this case it doesn't matter, but we really should make sure we understand what distance is. Distance is equal to the area underneath a velocity curve, v of t, from A to B, but to make it a distance, we want to make sure that all the velocities are positive. Okay, in this case, the velocities are all positive, so we don't have to worry about any negative terms in here. So in terms of the distance traveled, we're going to say that the distance traveled is 61 meters, okay, because the y-axis, the height, is in meters per second. We're multiplying that by width of seconds. And so meters per second times seconds gives us meters as our unit. So we've traveled a distance of 61 meters. Example 2. Use trapezoids to find the area under the curve of 4x squared plus 5. And that interval width is from -2 to 2. And we're going to divide this into 4 intervals. Okay, so I've sketched a graph here. I'm just going to draw that in. So from -2, from this point here to this point here. And we're going to divide this into 4 intervals. So it looks like at every whole number, we're going to divide this into interval widths. And when I connect those points to make trapezoids, I get trapezoids that look like this. Okay, so those are my 4 trapezoids. And then we're going to use that trapezoid the trapezoid formulas to calculate the areas. So the area is equal to, the first trapezoid is going to have a height of 21. So I plug in x is -2. So I get -2 squared times 4 is 16 plus 5. So that's going to be 21 plus. When I plug in -1, I'm going to get a y value of 9. So 21 times plus 9 divided by 2 gives me my average height. The interval width we're using is 1. Plus 9 plus, when I plug in 0, I get 5 divided by 2. Interval width is 1. So all these intervals widths are going to be the same. The nice thing about this is symmetrical. So this is going to be 5 plus 9 over 2 times the interval width of 1 plus 9 plus 21 over 2, interval width of 1. So we get an area. This is going to be 30 divided by 2 is 15 times 1. 14 divided by 2 is 7 times 1. So because of the symmetry of this, we can calculate this fairly quickly. So this area that I've calculated in here, these 4 trapezoids, I get a net area of 44 units squared.